Hey, hey, hey. I am back. I'm back again. Let's go to camera. I can show you people what I did, how far we are with the project. Okay, let's plug it in. Where is it? There. Okay, we already got all of our units displayed, which is what we want. Now we need to, instead of making this just overwrite everything, we need to actually be able to select. Hold on, there's a tripod leg in the way. How do I... let's get this underneath. Okay. There we go. Okay, so the plan is now, instead of making this thing override everything, to actually select between the microamps and seconds and then increase the values given there. So to do that, we will switch to the desktop and open our code. See, cloud, projects, random, this one, code. Let's make it a little bigger. Okay. And open the terminal. Now, how are we going to approach this? So this part tests whether we are going back or forth. Hold on. How does this work again? We check if the clock has changed and then we check if the not the derivative, the dt has changed. Is it delta t maybe? dt? I don't actually know what it stands for. So this one checks the turning of the button, but I'm pretty sure we also have let's see, button. Which pin would that be? So we already have 2, 4. I assume this one would be 8. I think it's 8. Yeah, it should be 8. 0x08, there we go. And this will mean the button is pressed, so this will make us switch between the units. Now how are we gonna indicate where we select the units? Actually, hold on, let's see if we can... Yes, this is important. We need to see if we can... Why are all my streams running? Hold on, that's not good. Let's pause all of those, or I can restore the session. That's nice. Let's see. Table of commands. Pretty sure we can set our cursor to blink. Display on off control. And we have the cursor. Blinking of cursor. Okay, let's see. Are we using anything where we set this bit? Probably init. This one. Well, what is C again? So confused. Hold on, 10 is A, 11, 12. So 8 plus 4, which would in our case be 8 plus 4. We don't set the cursor and we don't set blinking. What happens if we set both of those to 1? Oh, I need to... Hello, can I get out of this? Okay, there we go. Sudo change own to mir the actual serial thing, you know, the Arduino. I actually need permissions to write on that. So gcc to compile. Oh, I probably should do a -w all, so I actually get warnings if I mess up. Object copy and upload. There we go. Hold on. There we go. Now, we have a cursor. I don't think we need it to blink since... Let me show you. I think this underscore is the cursor and the blink is the blink. I would prefer the underscore. So we will set the blink to 0 again. And just the cursor to 1, which should be... What the fuck is happening? There we go. Compile, copy, send, go to the camera. Yeah, and now we have an underscore as a cursor. That's nice, that's nice. Let me drink something. Is my goddamn puppet frozen again? There's no way, right? Bruh. There we go. Okay, now you can actually see my movements. Nice. Okay. Now, what do we want? We probably want to set cursor to position 1 and 2, right? We want like a function for that. Void set cursor. Is that how you spell cursor? Probably. Uint underscore t position. Actually, we already have set address for this. There is no point. Oh, we need to figure out which we are currently on. So, how do we do that? Let's see, I think we read the address actually already in the... I'm still on the camera, what the fuck am I doing? There we go. I believe we already set the address in... Not init? Yeah, right RAM. Oopsie. Yep. Okay, set address, let's do uint 8 Scotty for an unsigned int, read RAM address uint 8_t address. No, wait, void. That's, we don't actually have parameters for this. And what this will do is do this. It will set the data direction to input, then read the address and set it back to output. And of course return address. Hello, address. There we go. Okay, we can delete this. This. And you are... No, wait. Read or... You know what? We're gonna get RAM address. So we have get and set. I think that's the proper way to call this. Get RAM address. Jesus Christ. This should work. Okay, let's see. Now, if we press the button, how do we want to change this? I believe we need to do a similar thing like here, where we detect the actual, the actual change in the button. And when the button changes, we want to test whether whether the current pointer address would be You know what, I think we should, after setting the time or the current, we should set the address to the first number of this. So we would set this to for the current would be 0, 1, 2, 3, 4, 5. I think 0, 1, 2, 3, 4. Yes, so set RAM address 5. That's actually the current, not the time. The time would be 15, 14, I think. And this would be 5. Okay, that way we always can check the address position. So we will uint 8_t address equals get RAM address. And then if the address, bro, I can't type, what is going on? Now if the address is, what did I say, 5? We want to switch the address to the other place, right? if address 5, we will switch this to set RAM, you know what, address equals 14, and bro, typing is hard, else address equals 5. Is there a way to make this more efficient? I'm pretty sure there is, right? I don't care. And after that, we will set RAM address 2. Anyone remember? Oh yeah, address, I am stupid. Bro, typing is actually impossible. Okay, we will compile, we will copy, and we will send. Now we will switch to the camera, turn it on, so you can actually see something. Oh yeah, and now I should be able to switch between these. Isn't that amazing? Hey yo, Kaiser Blue, how's it going? Look at all the progress we made. Okay, when I reset, I start at this point though, so I kind of want to change that to... Oh, hold on. I need to set this at the end, right? Let me show you my code. Because otherwise we will always switch to the lower position that way. Going good. Going good, you? How's the machine going? So I'm fine. Everything works well. And the machine is making progress. Yesterday was kind of a disaster stream because for some reason my PC needed to restart to actually recognize the Arduino. But since I was streaming, I couldn't restart the PC, so that didn't work. I really need to set up the server to handle any outages on my side. Okay, let's see. What is the next step? Yeah, damn. Also, I'm thinking of like different content strategies. I kind of want to have segments on stream that I can cut up into videos, but just programming isn't really a video, you know what I mean? So, I don't know, I need to think of something. Okay. Now, if I increase the... Oh, hold on, how would I do this now? Oh, I know exactly how I will do this. Hold on, yes. I will... Sounds like a good idea. Yeah. Yeah, I just need to think of something I can actually do. Oh, no, not you, and int. 8-bit integer, please. What do I call this? Direction. And this will... I think this will increase the direction. So direction equals 1. And this will decrease. Direction equals -1. Actually, we might want to increase the microamps by 10 times in like 10 microamp steps. Okay, now oh yeah, I need to do this. Yeah. Oh, by the way, see my new graphics? They look amazing. I also have like a just chatting screen, but I haven't set that one up yet. I can show you though. Cloud projects stream over, no, not overlay. Yes, overlay. Chatting overlay. That's the chatting overlay. That was the wrong button. How do I full screen this again? Maybe like this. Just pull it big. Yeah, there we go. I did have to fix the frame around the window though. It wasn't like, it looked like it was 16:9, but it wasn't. So 5. What will we do then? We will do set current with, what did I call this? Where are my constants at? Oh, current. Damn, bruh. I am very creative when it comes to names. Current plus, where's my plus? There's my plus. Direction times 10. And otherwise, yo, is carnival like carnival? What's the English name? Probably also carnival, right? It's Latin. I think it's Latin, yeah. Carna, goodbye meat or something. Is that like this week or something? I saw a party when I went shopping, or when I did groceries. When shopping sounds like I bought clothes. Set time plus direction. I think it's different from most regions. Really? That's weird. Okay, let's see if our code works. There we go. Can switch between these. Now can I increase the second? What the fuck? Yeah, I need to make it check that I can't decrease it past 0. Wait. Hold on, I need to increase this. Yeah, okay, I need to put in the overflow protection. For me it would be next week. Let me check on Carnival. Oh. Actually different regions have different Wait, no. Oh, we celebrated on different days, right? Carnival. Let's see, what's my state? Nope, that's... Like the actual holidays are the same, but the parade is different days. I always thought this would always be on Saturdays. Also, I don't know which one of these is which. Oh, this is the thing where you party. Yeah, that would be today. Damn. I didn't know that these were named after flowers. That's funny. Let's see, how would I do the overflow protection here? If time plus what would be faster? Calculating it again or probably calculating it again? Calculating it again. If time plus direction is no, how will I? If time equals 0 and direction equals -1, actually I wondered if it doesn't do is if it isn't that. So if time is not 0 or direction, no wait, hold on, if not both of these, so if time is unequal to 0 or no, I forgot how to flip around the and. I think that would be nor. I'm just gonna do the funny thing of exclamation mark and brackets. Weird. Okay. So if time is 0 and the direction is -1, we don't do this. Otherwise we do this, and then we, oopsie, do the same here for the current. This key. Oh my god, you just saw the camera the whole time. God damn it. Well, let's see. Okay, we can't decrease past 0, but we can increase. Isn't that amazing? And we can increase this. And simultaneously the value down there will increase. Okay, let's set this to 30 seconds and this to 200 microamps. Okay, I know the units of Li are technically wrong. This would be 16 point or something. Because I think for some reason it gets calculated in 0.1 milliamps times seconds, which is like 100 microamps steps. I don't know why. That's weird to me. But I don't really want to represent the fractions, so I decided I don't care. We are now calculating it in, you know. Okay. Now that this works, we can actually start doing some system theory. Or should we? Okay, I think first we need to... Never mind. First we need to get this off the cable. Put this on. Now I need to get some cables. 1 second. Oh, my arm is long enough. Computer Havoc, how you doing? We are currently calibrating a boost converter, so we can correctly set not set, so we get the correct. Can I get some actual cables that aren't like weird lengths? What is this? Why are they like 1 centimeter apart? What is this? Get me. I don't even know where I got all these cables from. It's just a bunch of random cables. Should probably buy like one coherent set for these at some point. Also, these are falling apart. Boost converter, yes. Well, I'm not actually doing the math for this because I have hold on. Oh yeah, I have a potentiometer over here, and this is how we will be doing that. So let's get our 5 volts out of this. 5 volts. Green is ground, I've decided. And we have Vn plus and Vn minus. Oh, that drew a lot of current. Cheater, yeah, that's me. Okay, I can't really test it on the board directly because if this is set to like 24 or 50 volts, I will fry all my electronics on there. We actually need, come on, 12 volts. Okay, now I just need to hit this. These 2 pins while also reading the display. What are we getting out? 4.6. Okay, let's try to increase that by turning this in one direction. Now we need to just remember that direction, which I will probably not do. Counterclockwise. Okay. Let's see, what do we get now? Instead of 4.6 we get nothing because this thing fell out. Come on. There we go. And put these 2 pins on there. Damn it. I need more hands. .5. Okay, I think I need to turn clockwise. This is gonna be a lot of turning. Oh boy. I hate these types of screws, you always slip. I like the... Actually, what are the English names for these screws? Like you have like the cross-shaped ones, the star-shaped ones, and the slits. Like we just call them slits, cross, and torque. Oh, and the hexagon shaped ones, those are Imbus in German. Come on. No. Oh, low battery guy, how are you doing in Kick Chat? Why is... Can I hit the screw, please? Actually, let's test how far... how far we've turned it so far. Put these two in. Get our voltmeter thing going. Wait. Seriously, the wrong direction? Bro, this is not the most accurate. Can I drop it and just measure like this? Okay. Why is it still 5 volts? Hello? Did I not turn this enough? What is the resistance over here? Hold on. How do I... Okay, we'll input this back in. Now let's measure it. There we go. Okay, we come out at nothing. And we're not hitting the pad, so we come out at 4.67 volts. Apparently this turning did not. Philips, Flathead, Torx and Allen. Oh yeah, Allen wrench I know. Oh no, Allen is like the outside hexagons, right? Where you put like the grips around and you turn. I meant the inside hexagons. Philips. Flathead. Flathead sounds like the head shape, not the actual screwdriver shape. Or is... Oh, Philips would be the cross shape then, right? Why is this thing not... Why do I have the feeling this thing is broken? Call it the slit. Oh, flathead. Interesting. Well, I hate flathead screws. Cross is a Phillips. Huh, interesting. Is that from the company Philips, or is that something different? V in, V out. Now V in, V in. And now measure V out. Oh shit, 18 volts. I read 18 volts. Where's read 18? I think we're over 20, are we? I think I turned too far. 26. Okay, yeah, I did turn too far. That is way too far, bro. I don't know, AI says it's because the design was developed in the 1930s by Henry F. Phillips. Oh. Yeah, that makes way more sense than the company name. That guy really developed a cross shape. Oh, maybe... Like there's the normal cross shape, right? But then there's also the one with the like the 45-degree turned cross, a smaller cross inside, right? Hold on. Phillips screw. Let's see images. Yeah, that's the normal cross shape. Ah, this. This is... No, this is not what I mean. Ah, Potsy drift. That's a weird name. Potsy drift. Where you have like the extra cross for some reason. I think the best nowadays is probably oh, Torx, yeah. Oh, hold on. You couldn't see that. I mean these ones where you have like the slits on the... like the tiny slits between the big slits for some reason. But I'm pretty sure the best designed ones are Torx. Like they are specifically... like they actually calculated for those ones. Wait, which one is plus? The top one. And this is minus. And now I can... Why is there nothing coming out? What's happening? Really 1 volt? Okay, apparently I don't have to turn as far as I thought I would. Let's go back counterclockwise a bit. Now if I had some pins that would actually hold in this, this would be a lot easier. Okay, how far are we now? 0.5 volts? What is happening? Why are we going down? Let me actually throw this away. I have to actively hold these. Let me get my oscilloscope. I can just attach the probes. Probably. Okay, let's see. There's a knot in my cables. We can't have that now, can we? Okay, now how will I... V in minus will just get a clamp. And V in plus will try to hook this tiny ass gap in here. Come on. I think I got it. Now I can simply... oh shit. It's the wrong way around. That's not good. How will I screw this now? Okay, let's see, what kind of voltage are we applying here? Not a lot. How many... okay, let's get this to baseline. 2 volts per divider, can I change that? That's the wrong channel, this one. 1 volt per divider. And okay, let's put this actually down here so I can... can I turn channel 2 off? Oh yeah, I can. Paste. Now 1 volt per divider, and oh, you can't see. So we want this line 5 dividers up. It's weird that it has a name. I guess it's called Pozidriv American. Yeah, I also, you can, pretty sure you can use the screwdrivers interchangeably. Oh my god, it's going down so fast. Oh, that's because I lost my pin connection. Get back in there. This is awkward. Damn it. I think no. Still in there. Okay, let's keep an eye on our line. I will try to get the screwdriver to fucking screw in there. This is really annoying to work with. Why is it a flathead? It isn't really changing the level all that much. I don't even know if we're going up or down. I am slipping so much. Okay, I think I got it. See, I think we're going down. We need the other direction. Oh no. Performance issues, yeah. I usually don't have those at the desk. That's happens in a different place. Are we going down or up with our voltage? Why is nothing happening? Do I need to plug it out and plug it in again? Okay, we're slowly dropping. Going in. I think we're back at 2 volts, aren't we? Climbing, that's very slow. very, very, what do you call it? The opposite of the exciting. Tension building. Maybe. Not really the opposite, but you get what I mean, right? Nope. I think I was screwing in the wrong direction. Let's, oops. Come on. No, cable fell out again. Do I not have a simpler way to connect this to 5 volts? There's no way, right? I thought we got up to 20 volts. What is happening? Why is nothing changing? How far can I screw this potentiometer? This is wild, bro. Huh. Okay, let's go back to our old measuring theory. I had it plugged in the wrong way. I'm losing it, bro. This is what I get for not checking. Okay, I think we can use this thing. Seems to be working, right? Okay, let's get this on there. Somehow get this thing. Underneath here. Whoops. This is working flawlessly. By the way. Oh shit. What? Oh. I guess we can access this now. That is too many volts. 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 Dios volts. Keep that shit in and start screwing around. Actually, that's... wrong channel. 5 volts per divider. Which direction are we going? I don't know if we're going... Oh, this is... Now we are finally talking. Right, we're on 12 volts, right? So... around here. There we go. Works for me. Now that we have calibrated this, we can... Oh, have you already seen our nice menu? And we programmed for our box. Oh, I need to put this thing back on. Thing like this maybe. Oops. Yeah, fine. Look at this beautiful menu. Can select between seconds and microamps. Then we can increase them. Isn't that amazing? Now we should also be able to... Actually, let's plug this one out. And... oh boy, this is gonna be... hold on. Where's my... yeah, this is an off-screen attachment process. Why is this part touching this part? That's not okay. I'm pretty sure. Oh Jesus. Oh, that's in, that's in. Beautiful. Now my fuse on the PC will die when I plug this in, probably. Holy, actually works. It doesn't work. Reset button. Trust. Oh, I probably plugged it out, didn't I? By pressing it in. Yeah. Now reset button. There we go. Nice. And now we can get our multimeter over here. And measure the voltage of this thing. Get my hand around the tripod. Okay. That's close enough for 12 volts. I'm taking it. Oh, also I have an actual power supply for this, where we can just plug this in here. Oh yeah. But we are currently programming it, so... you know. Okay, now we need to do some math. I know, you didn't expect that one, did you? First of all, do we need... yeah, I think we do need consistent frames for this. Would 1 kilohertz be enough? I wonder. It should be. Let's try it with our current interrupts we have available. So now the math is... hold on. Let us pull up our schematic. There we go. Okay, so we have... oh, actually we need to start using this first, I think, to get the correct output over here, so that this will modulate the 12 volts to whatever we want it to. Okay, that's MCP 4801. MCP 4801. datasheet. Jesus Christ. Sheet. This one? Do we have... Kinda don't want to download it, but I guess I have to. Let's put it into our datasheet stuff. Message delete by that was fast. Pin descriptions, general overview, serial interface, typical applications. Did I do this? 1 microfarad. I don't think so with filters. Over here, okay, no filters based, no microfarad based. I'm already loving my sketch. No filter on this one. Who needs filters? Am I right? Okay. Write command register. Shit, which one do I have? Let's scroll up. Should be somewhere. 8. This one is the one we have. 8-bit voltage output. 255 values. Show one channel, really? Just one channel? Oh, damn, interesting. Okay, this is probably pretty simple, isn't it? We have LDAC, which is... we have pin descriptions. There we go. Output synchronization input. This pin is used to transfer the input register to the output register. When this pin is low, Vout is updated with input register content. This pin can be tied to low if is desired at the rising edge of the CS pin. Okay, so we have tied this to low based. Then we have first we have DCA chip select and DCA shutdown. Hardware shutdown input. No further information on that one. Nice one. Let me zoom in for you guys. Okay, let's see. Chip select input. We have can we do a pull up? Or do we have to drive up and down? I don't know if we can do a pull up while pulling it down. Internal pull up, I mean. Let's see what we have. Pull up, yes. If XT pulled low. Or if externally pulled low. Honestly, I think we can just use this as an output port. Let's see, we have serial clock, serial data, okay. Performance curves, that's not what we want. Serial interface, this is what we want. Are designed to interface directly, blah blah blah. The C must be held low for the duration of the write command. The write command consists of 16 bits and is used to configure the DAC's control and data latches. Register 5 to 1, register 5.3 detail the input register that is used to configure the configure and load the DAC register for each device. Okay, let's see. We have the 8-bit one. So we would write... Wait, which one? Which bit do we start with? Does it say something about endianness? Following blah blah blah. Okay, we're just gonna trust that the see if it's the correct one. So what do we have? Oops. We have write to DAC register. Ouch. I need to sit correctly. Hold on. There we go. Okay, now my legs won't. Now my legs actually get some blood. Okay, we have random values. This is the value for some reason split into 2 bits, 2 bytes. Okay. This is 0. I assume we start with 0. Write to DAC register or ignore this command. Okay. Bit 14, don't care. GA output gain selection bit. I have to see what the output gain means. Then we have... Oh, one is 1 times V out equals V reference times D divided by 4th. That's a lot. Is this 12-bit maybe? Because that would mean we can only get like what? Like an eighth of the actual, no, 16th of the actual output. Of the actual input. That would not be good. Oh, we can do 2 times, so we could get an eighth. Where internal vref equals 2 volts. That's weird. What is vref? Yeah, that's a good question, isn't it? Shutdown control bit. Active mode operation, Vout is available. Shut down the device, analog output is not available, Vout pin is connected to 500 kilo ohms. That's probably irrelevant, let's just pulse it down. Actually, let's pulse it down or up. I need some general overview or something. This times dn divided by 2 to the power of n8. Okay, this is how we calculate our output. Our least significant bit, least significant bit. Jesus. Yeah, that's the least significant bit in this class. Least significant bit of each device. Okay, that's what I wanted to say. Now, The ideal voltage difference between two successive codes. Wait, what? What is this? Output voltage 1 LSB is the ideal voltage difference between two successive codes. Oh, so we slowly rise. So we also always want like oh, what? Oh no, that's just the least steps we can make. So 16 millivolts for double gain, or I think we need double gain, don't we? Yeah, we do need double gain. Because our reference value is 2 volts, output value would be 4 volts, which is already annoying. Because that way we won't actually get the full 12 volts. I thought it would be 5. Do I recalculate this? Maybe if we're not getting enough. Okay, interesting. So what do we need to set up this thing? Serial interface. We need this working. Let's just start to get this working. SPI. Slave select. No. We are master. So SPI interrupt enable. No. SPI enable. Okay, yes, we need to. Okay, let's start with our SPI setup function. How about that one? Set current, all of this stuff. Let's see where's our init function. Can put that below, right? Yeah, init. And print units. Void SPI setup. Also void, right? Yes. Void. Okay. SPI control register. That seems like an important thing. Let me drink something. SPCR. SPCR equals. Now, what do we need? Interrupt enable is 0. SPI enable is 1. Data order. Oh shit. Yeah, we need to figure that one out. Where is our thing? Do we have anything about endian? No. Order. Direction. Oh, I think we have it in the general overview. I thought I saw some. It's not, this is it. So clock cycles. This is the highest bit first, right? Zeros, something GA. Yes, highest bit first, okay. So we want 0, 1, order is 0, 0, 1, 0, master slave select. Let's see, master slave select. Okay, 1, so 0, 1, 0, 1. So this is 4, 5. 0, x, 5, and then C-pole, clock polarity. SEK is written high when idle. Okay. Leading edge rising, falling. What do we want over here? Oh, we have different modes, I guess. Can we get, I think, rising? What the fuck do I do with the modes? Where do I set these? I'm just gonna set, assume mode 0, so leading edge would be rising. So yes, leading edge rising. 0. Certain 0 is low and idle. Okay, 0. Clock phase. Jesus Christ, we're getting into it. Setting of clock phase bit determine if the data is sampled on the leading or trailing edge. Set up or sampled. Let's see. We set it up on the leading falling edge, right? So wait, what? Clock phase determine if the data is sampled on the leading first or trailing last edge. What the fuck? Yes, I want examples, thank you. Oh, there we go. For 0, we have boom sample here. Oh no, we are sampling on the first edge. So we want 0. So we have 0, 0, right? 0, 0. SPR1, what does that do? Oh god. Clock rate select. Oh boy. Yeah, what are our maximum characteristics over here, huh? What the fuck just happened? Oh. Probably performance curves, maybe? No, that's not it. Electrical character, that's probably it. Hardware shutdown, software shutdown, resolution. TNL, that's not it. Offset, gain. Internal reference voltage. Temperature, output noise. Phase margin. Short circuit settling time. With extended temperature. Wait, this is the same thing, just with SPI. There we go. Schmidt trigger high level event input. What that's, I don't know what the fuck that is. I just want somewhere nanoseconds. High clock time minimum 15 nanoseconds. Fall to rising clock edge 40 nanoseconds. How much is 1 nanosecond in 16 times 10 power of, let's see, megahertz, and we want 1 divided by this. Okay, nanoseconds is 9, right? So we already need... No, wait. Milli, micro, nano. We need 60 nanoseconds for 1 clock cycle. If I'm calculating this correctly. That means we can select the fastest clock we want, bruh. Hello? This is... Oh, pulse width 100. Okay, we might need to do like 2 clock cycles for that one, bruh. Okay, we can just select the fastest we want. That's nice. So, oscillator. Just divide by 2, so 8. So, both of these also 0. That makes this thing 0. Okay. Oh, I also need to set the slave select pin to output. I just don't know which one that is. Which one is that? I think the chip select pin is that. Might be. Who knows, who knows, who knows? That's something I'm gonna debug after I set the SPI up. Okay, SPI status register. Interrupt flag, right collision flag, double SPI speed bit. Oh yeah, I want this to set to 1. Will be doubled when SPI is in master mode. This means that the minimum... Yep. No, don't mark it. I don't know how to get out of this mode. How do I just want my text selection tool back. Why is it grayed out? What is this program, bro? SPSR. SPSR equals 0x01 to get double speed in master mode. There we go. Now I have a fucking pen. Why do I have a pen, bro? What is this? I want my mouse. No, don't print. Also don't save. This is fucking stupid. Can I just spam escape? Can I? Oh, I can answer like this. Oh, that's how that works. Okay, good. SPI data register. The SPI data register is read-write, blah blah blah. Writing to the register initiates data transmission. So receive buffer to read. Okay, we want to write this to send something. How about we will just, why is the S capital? Huh, what's going on here? Okay, let us SPI set up, and then we want to write what do we want to write? A5. So that would be SPIDR. SPIDR. Now SPDR equals 0x A5. Okay. Upload. Oh, yeah, of course. We need to actually get that. Now we can upload. Okay, now I'm gonna get my oscilloscope again, and we will switch to the camera. Oh, I need to figure out which one is the SPI pin. That's gonna be funny. Oh, I need to actually turn on my camera. Okay, one of these is the SPI pin, I am sure. Just which one, nobody knows. Can we read that underneath there? Okay, let's do a little research. What is my Arduino pinout saying? Huh? Which one of these is the... okay, let's just get the clock first, which would be probably the highest one. This one. Trust me, bro. Oh, I need a ground. Which one of these is ground? Hold on. How can I connect my ground now? This... oh, I can... I don't think I can do that. Maybe I can do that. Ooh. Nope, I cannot do that. Oh, I can do that. Oh shit, that's a shot. This is ground, okay. Normal. We are not sending anything. I don't think that's good. We should be sending stuff. Oh, I need to probably zoom in here. There we go. Yeah, okay. We are not sending anything. That's kind of unlucky. But we probably also need to configure all the ports to output, don't we? Let's see. Init. DDR SPI. The fuck does that mean? Okay. Which pins are these? We need our slave select is output, so this one is out, this one is out, this one is in, this one is out. So these two and this one out, this one, I actually know what the fuck that one does. What is that, PB1? D9, I think. Oh, DCA shutdown. We need that one also out. So the first is everything is out. Where's my init function? DDRB. Here everything is out. And this one has in, out, so 2. Are we serious? That's probably because I shorted it and the fuse got blown. Damn it. Okay. Send. Oh yeah, now we're talking. Okay, now we are writing something. Damn, this pin is dangerous to use like that. Oh, I can put it on. Okay, I found a pin I can use for ground. Oh, hold on, actually. Let's get this on the camera. Oopsie. And I will again. Oh boy, it's gonna be finicky. This one will have to go. Ooh, can I zoom out? Cannot zoom out further. This ground will be connected to this. You will be connected to this. Oh boy. And this will be connected to, oh boy, this thing. Okay, there we go. And now let me enable the second channel. And actually set this to a reasonable thing. Oh my god, it's bouncing so hard. That's so funny. Okay, let's get single. Zoom in. Get a new one. Set the trigger at somewhere here. Oops, zoom in again. Okay. Now let's see. Do we actually have... Are we actually sending what I wanted to send? We are 1 clock cycle. 1 0 1 0 0 1 0 1. It's sending what I wanted to send. It's fucking working. Let's go. Also, this looks pretty funny. Meow, meow, meow. Okay. SPI is sending. That's all I wanted. Let's get this out. Nice, nice, nice. Okay. Now. We need to actually send some real data. Right? So, how often do we want to send? Let's go back to our characteristics. There has to be like a time between sending, right? CASH maybe? No. Data input setup time. Data input hold time. Oh, idle time before this fall. Okay, this is all in nanoseconds. We don't pulse this one, so we don't care about that one. Oh, we need to start actually respecting our port B register, don't we? Port B. Port B. Yeah, we need to start respecting here. How do I pull one pin low? I will have to do the AND, and then I will have to invert the first, do the same thing here, and this one will just have the AND to set it high. Yes, yes. Okay, next. Same thing here. Oopsie. And this one gets... Oh, wait, what? Yep, this one is actually high. And we will have to respect it here too. So this one... high, low. At the start we can set it low. That's fine. Okay. Now we are respecting the integrity of our port B register. And I want a bunch of support functions for our SPI. Void send DAC unsigned int 8 Jesus Christ underscore T data and we need to figure out which one is hold on. Here's our chip select bit, which we will is for some reason inverted, so I'll set up SPI. Yes, yes, yes. We will get our shutdown is true when we are low, so we want this high. D9, what is that? D9 would be this one. Port B. Wait, hold on, I am stupid. We don't set it high like this. We set it high like this. Right. I always mix these three keys up, it's so annoying. This one. Yeah, that was the last one. And we will set some of these pins high, and that is the shutdown pin. And let's see what else. What the fuck is D12? Master in, slave out. We're actually using this for something else. That's kind of funny. Wait, doesn't that get overridden by the SPI? That would be really annoying. Input. Direction master SPI input. It's overridden. Can we still read it? I hope so. Okay. So this one is low. Low by default. I need to... Oopsie. Okay, chip select is high by default. Okay. So these two are high. D9 and D10. This is low by default. This is irrelevant. This is irrelevant. So D9 and D10 need to be high, which would be 2, 4, 6. 0x06. I'm not stupid, right? No, 6, yes. 6. Yeah. Okay. That makes sense. Now, the first thing we need to do to send is port B and set the chip select bit low, which I forgot which port that was. That was the, yeah, 4, okay. So invert 0x04, and then we will send this stuff. Oh, can I continue sending afterwards? I think so, right? Ooh, doesn't say. Oh yeah, I can immediately send afterwards. Okay, that's great. I will have to wait while SPI is busy, so... Oh, I will need to send 2 bits actually, that's what I need to send. Oh no, I need to send just this. And 0, I don't know, 0 again. Oh, this was 2, I guess, and shutdown is 1 because it's inverted shutdown, so it's active. Okay. Uint 8 underscore T high equals what are we doing for this one? We need 0x right 0 0. Our GA was something funny. I think we need this 2 because where's the formula? This is annoying. General overview, there we go. G needs to be 2 so we can actually get to 4 volts. So where's my, there we go. 0 0 0 and 1. So you are actually a 1 0. And on top of that we will get the top 4 bits of data. So we need to shift those, sadly. How do we... So first we need to actually 0x F0 and data. And we shift that over by 4 bits. Right? We have 1, 2, 3, 4, yes. 4 bits, there we go. And we also have the low byte, which is just data low and some random stuff. So can delete that. We shift this in the other direction. And we need 0f. Actually, we don't need to add that because it will... Oh, how does the shift work? Does it wrap around? AVR shift don't know. You know what, to be safe, let's keep that in and shift it by 4 to the other side. Actually, you can go on top of that. Okay, we have our data now. Now we need to send... How do we send again? Hold on. I got this. Okay, this one. Okay. But you will have high. Then we need to wait while it is busy. Where is our busy flag again? Interrupt flag, write correlation flag, data register. Where's the busy flag? Oh. SPI status. My serial transfer is complete. This flag is set. An interrupt is generated. I don't want the interrupt. Okay, so this is our busy flag. While that is 0, how do I clear that? SPI is cleared when by hardware when executing the corresponding. Alternatively is cleared by first reading the SPI status register, then accessing the SPI data register. So should be automatically cleared. Let's test by while. Hold on, I forgot the name. SPSR. SPSR. And oh, exclamation mark. This and 0x80. Okay, continue while this is not set. After this is set. Oops. Low. What the fuck did I do? Okay, wait again, and then we will simply... I need to access it again, but I don't want to write it, so I want to read it. But I don't want this to get optimized away. That's... How do I get this not optimized away? Oh, I can send. I could maybe try to Low equals SPDR. Let's test if that works. Access to clear interrupt flag. Compile. Oh. What do you mean low is undeclared? Is this really declared here? What are you, huh? Oh. Oh. Not my smartest move, I admit. Object copy and upload. I actually don't execute this, do I? And that's SPI setup. What the fuck did I call this? Init send DAC. Send DAC. What do we want it to send? 200. Compile, copy, send. Okay. You know what? Let's see if we actually have a voltage over here. Let's go for the camera. Yeah, come on. There we go. Now let's see. We do not have a voltage. Kind of expected, not gonna lie. But that is something we can debug tomorrow. Because it is late and I need to sleep. Oh yeah. Oh fuck, my leg already fell asleep. That's not good. Okay, there we go. Oh no, oh boy. Yep, I'm feeling the white noise in my leg. Let's delete a couple lines here because I don't like them. Okay. Well, that's it from me. I will go to sleep. Love you all parasocially and your moms romantically. Bye bye.